What if everything we see, touch, and experience is just the tip of an unimaginable iceberg? What if the reality we know is merely a shadow of something far grander, something hiding in dimensions we can't even perceive? Today, we're diving into the unknown, exploring 30 mind-bending theories about the hidden dimensions of reality. From the tiny vibrating strings that might make up the fabric of the universe to the possibility that our entire existence is a hologram, each theory will challenge everything you thought you knew about space, time, and beyond. Get ready to question the nature of reality itself as we unravel these extraordinary ideas one by one. Stay with us, because by the end of this journey, you might just see the universe in a whole new light. Let's begin. Now, let's take our first step into the extraordinary with string theory. Imagine the universe not as a collection of particles, but as a symphony of tiny, vibrating strings. These strings, so small that they're beyond our current ability to observe, are thought to be the fundamental building blocks of everything in existence. Each vibration corresponds to a different particle, like a note in a cosmic melody. This theory doesn't just stop at redefining matter, it opens the door to the possibility of multiple dimensions. While we experience just 3 dimensions of space and 1 of time, string theory suggests there could be as many as 10 or even 11 dimensions, all curled up and hidden from our perception. What's even more fascinating is how string theory aims to unify the 4 fundamental forces of nature: gravity, electromagnetism, the strong nuclear force, and the weak nuclear force. In this framework, everything from the smallest particle to the vastness of gravity might be connected through these vibrating strings. It's a bold idea that challenges our understanding of reality, offering a glimpse into a universe far more intricate and interconnected than we ever imagined. Building on the foundation of string theory, let's venture further into the unknown with M-theory. This intriguing extension takes the concept of vibrating strings and pushes it into even more mysterious territory. M-theory proposes that our universe isn't just governed by 10 dimensions, as string theory suggests, but by 11. That extra dimension might seem small, but it's a game changer. It acts as a kind of glue, connecting different versions of string theory that were previously thought to be incompatible, creating a unified framework. This unification helps explain phenomena that earlier theories couldn't fully address, like the behavior of black holes or the origins of the cosmos. But perhaps the most exciting aspect of M-theory is its connection to the multiverse. It suggests that our universe could be just one of countless others, each existing on its own membrane or brain, floating in a higher dimensional space. These brains might collide, creating events like the Big Bang, or drift apart, forming entirely new universes. M-theory doesn't just expand our understanding of dimensions. It opens the door to a cosmos filled with infinite possibilities, where reality as we know it is just one piece of an unimaginably vast puzzle. Now let's shift our perspective entirely and explore a theory that turns our understanding of reality on its head: the holographic principle. At first glance, the idea that our 3-dimensional universe could be a 2-dimensional hologram might sound like science fiction. But this concept has deep roots in physics, particularly in the study of black holes. The holographic principle suggests that all the information about a 3-dimensional space can be encoded on a 2-dimensional surface, much like how a hologram projects a 3D image from a 2D surface. This mind-bending idea emerged from attempts to solve one of the most puzzling problems in physics: the information paradox of black holes. When matter falls into a black hole, it seems to disappear forever, but according to quantum mechanics, information cannot be destroyed. The holographic principle offers a solution, proposing that the information about everything swallowed by a black hole is stored on its event horizon, the boundary beyond which nothing can escape. This principle doesn't just apply to black holes. It suggests that the entire universe might operate this way. our perception of a three-dimensional world could be a projection of information stored on a two-dimensional surface at the edge of the cosmos. If true, this would fundamentally change how we understand space, time, and reality itself. It challenges the very nature of what we perceive as tangible and immediate, hinting that the universe is far more interconnected and enigmatic than we ever imagined. The holographic principle doesn't just expand our view of the cosmos, it rewrites the rules of reality, inviting us to rethink everything we thought we knew. Now, let's take a step into a theory that reimagines the very fabric of our universe, the brain-world scenario. Imagine our universe not as a standalone entity, but as a membrane or brain floating in a higher dimensional space. This idea suggests that what we perceive as our three-dimensional world is just one layer in a much larger, multidimensional reality. The brain-world scenario comes from the idea that there could be extra dimensions beyond the familiar three of space and one of time, but these are hidden from our everyday experience. These extra dimensions might be compactified or folded up at such a tiny scale that we can't detect them directly. Now, here's where it gets really interesting. This theory could explain one of the most puzzling aspects of physics: why gravity is so much weaker than the other fundamental forces. In the brain-world model, gravity might be the only force that can leak into these higher dimensions, spreading out and diluting its strength in our observable universe. This would explain why gravity feels so feeble compared to the electromagnetic force or the strong nuclear force, which are confined to our brain. It's like trying to hear a whisper in a vast, echoing hall. The sound disperses and becomes faint. If the brain-world scenario is correct, it would mean that our universe is just one layer in a cosmic tapestry, with gravity acting as a bridge between our reality and unseen dimensions. This idea not only challenges our understanding of space and time, but also opens up new possibilities for exploring the nature of the cosmos. As we continue our journey through these theories, let's keep in mind that the universe might be far more complex and interconnected than we ever imagined. Moving further into the realm of hidden dimensions, let's unpack the intriguing concept of compactified dimensions. This theory suggests that the extra dimensions we've been discussing aren't missing or absent, they're simply too small for us to notice. Imagine a garden hose stretched out across a field. From a distance, it looks like a one-dimensional line, but if you zoom in, you'll see it's actually a tube with a circular cross-section. In the same way, compactified dimensions are curled up so tightly, at scales far smaller than an atom, that we can't perceive them directly. This idea isn't new, it traces back to the early 20th century and a groundbreaking theory developed by Theodore Kaluza and Oskar Klein. Their work proposed that by adding an extra spatial dimension to Einstein's theory of general relativity, they could unify gravity with electromagnetism. The extra dimension, though compactified, allowed for a richer mathematical framework that hinted at a deeper structure of the universe. Think of it like a sheet of paper rolled into a tube. The paper's surface is still there, but its shape changes how we experience it. In this model, the compactified dimensions could hold the key to understanding why our universe appears three-dimensional at large scales, even if it's built on a more complex, multidimensional foundation. This theory not only laid the groundwork for modern string theory, but also opened the door to exploring how hidden dimensions might shape the fundamental forces and particles we observe today. As we continue unraveling these theories, it's clear that the universe's true nature might be far more intricate and far more compact than meets the eye. Now, let's shift our focus to a fascinating theory that reimagines the origins of our universe, the ekpyrotic universe. This idea challenges the traditional Big Bang cosmology by proposing that our universe wasn't born from a singular explosion, but rather from the collision of two brains in a higher dimensional space. To put it simply, brains are like multidimensional membranes that exist within this larger framework. And according to this theory, our universe is just one of these brains. Picture two sheets of paper floating in a vast, invisible space. When they collide, the energy from that impact creates the conditions for a universe to form. This collision is what the ekpyrotic scenario suggests sparked the Big Bang, setting in motion the expansion of space and the birth of matter as we know it. Unlike the traditional Big Bang model, which starts with a singular point of infinite density, the ekpyrotic universe offers a smoother beginning, avoiding some of the paradoxes and infinities that arise in classical cosmology. It's a bit like comparing a sudden explosion to a controlled collision. The end result might look similar, but the process is fundamentally different. This theory also ties back to earlier ideas about hidden dimensions, suggesting that these higher dimensional spaces play a crucial role in shaping the universe's structure. By exploring the ekpyrotic universe, we're not just rethinking the Big Bang, we're expanding our understanding of how dimensions beyond our own might influence the very fabric of reality. As we continue our journey through these theories, it's clear that the universe's story might be far more complex and far more interconnected than we ever imagined. Now, let's take a step into a concept that stretches the boundaries of imagination: the multiverse hypothesis. This theory suggests that our universe isn't the only one out there. Instead, it's just one of countless universes, each with its own unique set of physical laws and dimensions. Think of it like a vast cosmic library, where every book represents a different universe with its own story, rules, and possibilities. Some universes might be eerily similar to ours, with only tiny differences, while others could be so alien that they're beyond our comprehension. This idea challenges the notion that our universe is all there is, opening up the possibility that what we see and experience is just a small fraction of a much larger, more diverse reality. The multiverse hypothesis also ties into the concept of hidden dimensions, suggesting that these extra dimensions could be the key to understanding how multiple universes coexist. Some theories propose that these universes are separated by unimaginably vast distances, while others suggest they're stacked like pages in a book just out of reach. What's fascinating is that this idea isn't just science fiction. It's grounded in serious scientific thought, from quantum mechanics to string theory. By exploring the multiverse hypothesis, we're not just speculating about other worlds, we're questioning the very nature of existence itself. Could there be a universe where gravity is weaker or where time flows backward? The possibilities are endless, and as we continue to unravel these theories, we're reminded just how mysterious and multifaceted the cosmos truly is. Now, let's shift our focus to a theory that takes the idea of multiple universes to an entirely new level: the many worlds interpretation. This fascinating concept emerges from the realm of quantum mechanics, suggesting that every decision, no matter how small, creates a branching of universes. Imagine standing at a crossroads where every path you could possibly take actually splits off into its own reality. In one universe, you might choose to turn left, while in another, you go right. Each choice spawns a new world, each with its own version of events unfolding independently. But here's where it gets even more intriguing. This theory isn't just about parallel decisions. It's deeply connected to the idea of hidden dimensions. Some physicists propose that these branching universes might exist in higher dimensions, layers of reality stacked upon one another like sheets of paper. This could explain why we're only aware of our own timeline. These alternate realities are tucked away in dimensions we can't perceive. The many worlds interpretation challenges us to rethink not just our place in the cosmos, but the very nature of choice and possibility. If every outcome exists somewhere, what does that mean for free will? And how do hidden dimensions play a role in this vast, interconnected web of realities? As we explore this theory, we're not just questioning the mechanics of the universe, we're delving into the profound implications of existence itself. Now, let's turn our attention to a theory that blurs the line between science and philosophy: the simulation hypothesis. This idea suggests that our entire reality could be an incredibly advanced computer simulation created by a civilization far more technologically advanced than our own. Think of it like this: just as we create virtual worlds in video games with characters who are unaware they're part of a simulated environment, we might be living in a similar construct. But here's where it gets mind-bending. This theory isn't just a sci-fi concept. Some scientists and philosophers argue that if a civilization could reach a certain level of technological sophistication, it would be entirely possible for them to create a simulation so detailed its inhabitants would believe it's real. And what if this simulation is running in a higher dimensional framework? Hidden dimensions could explain the computational power needed to sustain such a complex reality, as well as the strange behaviors we observe in quantum mechanics. The simulation hypothesis raises profound questions about existence itself. If we're living in a simulated world, what does that mean for our perception of reality? Are our choices truly ours, or are they pre-programmed? And if this is a simulation, who or what is the programmer? While this theory remains speculative, it challenges us to think deeply about the nature of consciousness, free will, and the very fabric of the universe. Whether you find it unsettling or exhilarating, the simulation hypothesis forces us to confront the possibility that reality might be far stranger than we've ever imagined. Shifting our perspective, let's explore the cosmic landscape theory, a concept that suggests the universe's fundamental constants and physical laws might be shaped by hidden dimensions. Imagine the universe as a vast, ever-changing terrain, where each region represents a different set of rules governing reality. These hidden dimensions could act as the architects of this landscape, determining how particles interact, how forces behave, and even the very fabric of space and time. What's fascinating is that this theory doesn't stop at our observable universe. It proposes the existence of countless other regions within this cosmic landscape, each with its own unique physical laws. Some might be similar to ours, while others could be wildly different, perhaps even hostile to life as we know it. This idea ties into the multiverse concept, suggesting that our universe is just one of many possible realities, all coexisting in a higher dimensional framework. The cosmic landscape theory also offers a potential explanation for one of the biggest mysteries in physics: why the constants of nature, like the speed of light or the strength of gravity, seem so finely tuned to allow for life. If hidden dimensions are shaping this landscape, it could mean that somewhere out there, there's a universe where these constants are entirely different. While this theory is still speculative, it opens up a breathtaking vision of reality, one where the universe is not a single, static entity, but a dynamic, multidimensional tapestry of possibilities. As we continue to explore the mysteries of the cosmos, the cosmic landscape theory reminds us that reality might be far more complex and interconnected than we've ever imagined. Building on the idea of the cosmic landscape, we now turn to a theory that attempts to answer one of the most profound questions in science: why does our universe seem perfectly suited for life? This brings us to the anthropic principle, a concept that suggests the universe's properties are precisely what they are because if they weren't, we wouldn't be here to observe them. But how does this relate to hidden dimensions? If these extra dimensions exist, they could play a crucial role in fine-tuning the conditions that make life possible. Imagine a universe where hidden dimensions dictate the strength of gravity, the behavior of particles, or the stability of atoms. In such a universe, even tiny changes in these dimensions could render life impossible. This is where the anthropic principle steps in. It proposes that, among countless possible universes in the multiverse, only those with the right combination of properties shaped by the right hidden dimensions can support conscious beings like us. In other words, we exist in this universe not by chance, but because it's one of the rare ones where everything aligns perfectly for life. This idea ties back to the multiverse concept, suggesting that hidden dimensions might be the key to understanding why we find ourselves in a universe that feels so finely tuned. While the anthropic principle doesn't provide all the answers, it offers a compelling perspective on the mystery of life-friendly conditions, hinting that hidden dimensions might be the unseen architects of our reality. Shifting our focus to the unpredictable, let's delve into the fascinating idea of the butterfly effect in higher dimensions. You've likely heard of the butterfly effect in chaos theory, where a small change in one system can lead to drastic consequences elsewhere, like a butterfly flapping its wings, potentially causing a tornado halfway across the world. But what if this principle isn't limited to our observable three-dimensional space? Imagine hidden dimensions, tightly coiled or existing beyond our perception, where even the tiniest fluctuation could ripple out and dramatically alter the fabric of our reality. These extra dimensions might act like a hidden layer of influence, amplifying effects that seem insignificant in our world. For instance, a shift in the geometry of these dimensions could change the behavior of particles, alter the strength of fundamental forces, or even warp the structure of spacetime itself. This means that what we perceive as random or chaotic events in our universe might actually be the result of subtle, unseen movements in these higher dimensions. The implications are staggering. It suggests that the universe operates on a far more intricate and interconnected scale than we ever imagined. By drawing parallels to chaos theory, the butterfly effect in higher dimensions challenges us to rethink how we understand cause and effect, opening up new possibilities for exploring the mysteries of existence. Turning our attention to the quantum realm, let's explore the intriguing connection between the Casimir effect and the possibility of extra dimensions. The Casimir effect is a fascinating phenomenon in quantum physics where two uncharged parallel metal plates placed incredibly close together in a vacuum experience an attractive force. This force arises from the quantum fluctuations of the vacuum itself, the so-called zero-point energy that exists even in empty space. But here's where it gets even more interesting. Some scientists propose that this effect could hint at the existence of hidden dimensions. According to certain theoretical models, the force observed in the Casimir effect might not just be a result of quantum fluctuations in our familiar three-dimensional space. Instead, it could also involve interactions with extra dimensions that are compactified or curled up at incredibly small scales. These hidden dimensions could subtly alter the behavior of the vacuum energy, influencing the strength and nature of the Casimir force. If experiments could detect deviations from the predicted force that can't be explained by our current understanding of physics, it might provide indirect evidence for these extra dimensions. This makes the Casimir effect a potential bridge between the abstract world of theoretical physics and the concrete realm of experimental observation. By studying this phenomenon, we might uncover tiny, almost imperceptible clues that could reshape our understanding of the universe's hidden layers. The implications are profound. It suggests that even the most subtle quantum effects could be windows into dimensions beyond our perception, offering a glimpse into the deeper architecture of reality. Now, shifting our focus to the interplay between gravity and the quantum world, let's explore how theories of quantum gravity might bridge the gap between these two pillars of physics while shedding light on hidden dimensions. At its core, quantum gravity seeks to reconcile the principles of quantum mechanics, which govern the behavior of particles at the smallest scales, with Einstein's theory of general relativity, which describes gravity as the curvature of spacetime. One prominent approach is loop quantum gravity, which proposes that spacetime itself is woven from tiny, discrete loops. These loops form a network, creating a fabric that's fundamentally granular rather than smooth. But here's where hidden dimensions come into play. Loop quantum gravity doesn't just stop at our familiar 4 dimensions of spacetime. Some versions of the theory suggest that these loops could extend into higher dimensions, offering a potential framework for understanding how extra dimensions might influence the behavior of gravity at the quantum level. Another intriguing idea is that hidden dimensions could help explain why gravity appears so much weaker than the other fundamental forces. In higher dimensional space, gravity might spread out and become diluted, which could explain its faint presence in our three-dimensional world. Theories like loop quantum gravity also hint at the possibility that the Big Bang wasn't an explosion from a single point, but rather a transition from a previous universe's collapse, with hidden dimensions playing a key role in this cosmic cycle. By exploring these theories, we're not just trying to unify gravity and quantum mechanics, we're also uncovering clues about the universe's hidden structure. This connection between quantum gravity and extra dimensions opens up a new frontier in our quest to understand reality's deepest layers, where the smallest scales and the largest mysteries intertwine. Moving deeper into the mysteries of the cosmos, let's consider the enigmatic nature of dark matter and how hidden dimensions might hold the key to understanding it. Dark matter, which makes up roughly 27% of the universe, is invisible to us because it doesn't interact with light or any other form of electromagnetic radiation. Yet, its presence is felt through its gravitational effects on galaxies and galaxy clusters. So, what if dark matter's elusive nature is tied to hidden dimensions? Some theories propose that dark matter particles could reside in higher dimensional spaces, interacting weakly with our three-dimensional world. This would explain why we can't directly detect them. They might be leaking into our universe just enough to exert gravity, but not enough to be seen or measured in conventional ways. Another fascinating idea is that dark matter could be composed of particles that move freely through these extra dimensions, making them inherently difficult to detect. This interaction with hidden dimensions might also explain why dark matter doesn't clump together like ordinary matter, but instead forms vast, diffuse halos around galaxies. By exploring this connection, we're not just trying to solve the dark matter puzzle, we're also uncovering clues about the universe's hidden architecture. Could dark matter be the bridge between our observable reality and the higher dimensions that might surround us? This theory opens up a new dimension of questions, challenging us to rethink what we know about the universe's invisible scaffolding. While dark matter challenges our understanding of the unseen, dark energy presents an even greater cosmic mystery. Let's shift our focus to the force driving the universe's accelerated expansion and how hidden dimensions might play a role. Dark energy, which makes up roughly 68% of the universe, pushes galaxies apart at an ever-increasing rate. Yet, its true nature remains one of the biggest unanswered questions in science. Could higher dimensions hold the key? Some theories suggest that dark energy's influence might stem from interactions within these hidden dimensions. Imagine that the energy permeating these extra spaces exerts a subtle but constant pressure on our observable universe, causing it to expand faster over time. Another intriguing idea is that dark energy is a manifestation of the curvature or geometry of these higher dimensions. Just as a ripple on the surface of a pond hints at deeper movements beneath, the effects of dark energy could be a sign of dynamic activity in dimensions beyond our perception. What's more, the presence of extra dimensions might explain why dark energy's density remains constant even as the universe expands, a puzzle that defies conventional physics. By exploring this connection, we're not just unraveling the mystery of dark energy, but also uncovering how hidden dimensions could shape the very fabric of reality. Could this elusive force be the fingerprint of a higher dimensional universe interacting with our own? This theory invites us to think beyond the limits of our three-dimensional world and explore the profound ways unseen dimensions might influence the cosmos. Now, let's turn our attention to a theory that reimagines the very beginning of the universe. The Big Bounce theory proposes a fascinating alternative to the Big Bang. suggesting that our universe is part of an endless cycle of expansion and contraction. Instead of a single explosive beginning, this theory envisions a cosmos that collapses and rebounds in a continuous loop. Imagine the universe as a giant cosmic heartbeat, where each beat represents the birth and death of a universe. In this scenario, the Big Bang wasn't the start of everything, but rather a moment of renewal, a bounce from a previous universe that had collapsed in on itself. Hidden dimensions could play a crucial role in this process. Some physicists suggest that these extra dimensions might influence how space contracts and expands, acting as a kind of cosmic spring that allows the universe to bounce back. This cyclical model also raises intriguing questions about time and structure. If the universe has undergone countless cycles, could traces of previous universes still exist in the fabric of space-time? And what role do these hidden dimensions play in shaping the conditions for each new cycle? The Big Bounce theory not only challenges our understanding of the universe's origins, but also opens up the possibility that we're part of an eternal cosmic rhythm, with dimensions beyond our own guiding the ebb and flow of existence. Building on the Big Bounce theory, the cyclic model takes us one step further into the idea of a universe that endlessly repeats itself. This model suggests that the cosmos doesn't just collapse and rebound, but does so in a way that's deeply connected to hidden dimensions. Picture our universe as part of a grander system, where these extra dimensions act as a kind of framework, guiding the cycle of expansion and contraction. Just as a coiled spring stores energy, these hidden dimensions could hold the key to how the universe bounces back after collapsing. In this framework, the Big Bang isn't a one-time event but a recurring phenomenon, driven by the interplay between the dimensions we see and those we can't. What's fascinating is how this model ties into the distribution of matter and energy in the universe. Hidden dimensions could influence the way matter spreads out after each bounce, shaping the conditions for the next cycle. This raises questions about whether there's a pattern or rhythm to these cycles. Could hidden dimensions leave behind some kind of imprint or signature from previous iterations of the universe? And if so, how might we detect it? The cyclic model not only offers a fresh perspective on the universe's lifespan, but also highlights the potential role of these unseen dimensions in shaping the very fabric of reality. As we explore this idea, it becomes clear that the universe might be far more dynamic and interconnected than we ever imagined, with hidden dimensions playing a vital part in its eternal dance. Now, let's shift our focus to one of the most enigmatic phenomena in the cosmos: black holes. These cosmic giants, known for their immense gravitational pull, might hold secrets far beyond our current understanding. One of the most intriguing theories suggests that black holes could act as gateways to hidden dimensions. At the heart of a black hole lies the singularity, a point where gravity becomes infinitely strong and the laws of physics as we know them break down. Some physicists propose that this singularity isn't just a dead end but a portal to other regions of spacetime or even entirely different dimensions. Imagine black holes as cosmic tunnels, not just devouring matter and light, but potentially connecting our universe to other realms that exist beyond our perception. This idea ties into the concept of higher dimensions, where the fabric of reality could be far more complex than the three dimensions of space and one of time we experience. If black holes do serve as gateways, they might explain some of the mysteries surrounding their behavior, such as the way information seems to vanish into them, only to possibly reappear elsewhere. This theory also raises exciting possibilities for understanding the nature of spacetime itself. Could black holes be the key to unlocking the mysteries of hidden dimensions, offering us a glimpse into a reality that's far more interconnected than we ever imagined? As we continue to explore these cosmic phenomena, it's clear that black holes are not just destroyers of worlds but potential bridges to realms beyond our current understanding. Now, let's turn our attention to another fascinating concept that could reshape our understanding of the cosmos: wormholes. Often depicted in science fiction as shortcuts through space and time, wormholes are not just the stuff of imagination. They are theoretical tunnels through space-time predicted by the equations of general relativity. These structures, if they exist, could connect distant parts of the universe, or even entirely different universes, providing a shortcut across vast cosmic distances. But here's where it gets even more intriguing. Some scientists believe that wormholes might also serve as pathways to hidden dimensions. Imagine a tunnel not just linking two points in our universe, but opening a doorway to realms beyond our familiar 3 dimensions of space and one of time. This idea suggests that wormholes could be more than just cosmic bridges. They might be gateways to higher dimensions where the rules of physics could be entirely different. For instance, a wormhole could theoretically connect our universe to a parallel universe with its own unique physical laws. While wormholes remain purely theoretical at this point, they offer a tantalizing possibility for understanding the deeper structure of reality. Could these space-time tunnels be the key to unlocking the mysteries of hidden dimensions? The idea challenges us to think beyond the boundaries of our observable universe and consider a reality that's far more interconnected than we ever imagined. As we explore these concepts, wormholes continue to captivate our curiosity, offering a glimpse into the profound complexities of the cosmos. Now, shifting our perspective, let's consider a dimension that's both familiar and mysterious: time itself. We often think of time as a linear progression, moving steadily from past to present to future. But what if time is more than just a one-directional flow? Some theories suggest that time could be a hidden dimension, intricately woven into the fabric of reality. Imagine a higher dimensional framework where multiple timelines coexist, each representing a different sequence of events. This idea challenges our conventional understanding, proposing that every moment in time might exist simultaneously, stacked like pages in a book. Picture a universe where the past, present, and future are all equally real, with each timeline branching off into infinite possibilities. This concept isn't just speculative, it's rooted in certain interpretations of quantum mechanics and relativity. For instance, the block universe theory suggests that time is a fourth dimension, where all events are fixed in a 4-dimensional spacetime block. From this perspective, our perception of time as a flowing river might be an illusion, and what we experience as now is simply our consciousness moving along this dimension. The implications are profound. If time is a hidden dimension, it could mean that alternate versions of history, or even alternate futures, are just as real as our present. This idea opens up thrilling possibilities, from revisiting past events to glimpsing potential outcomes. While the nature of time remains one of the greatest mysteries in science, exploring it as a hidden dimension invites us to rethink our place in the cosmos. Could time be the key to understanding the deeper layers of reality? As we ponder this question, we're reminded that the universe is far more intricate and far stranger than we often imagine. Now, let's take a moment to explore a truly mind-bending idea. What if consciousness itself is intertwined with the hidden dimensions of reality? This theory suggests that our awareness, our sense of self, might not be confined to the physical world as we know it. Instead, consciousness could interact with higher dimensions, shaping how we perceive and experience reality. Think of it this way: what we see, hear, and feel might just be a fraction of what's truly out there. Some researchers propose that consciousness acts like a bridge, connecting us to these hidden dimensions and allowing us to interpret the universe in ways we barely understand. This isn't just philosophical speculation, it's a notion that's gaining traction in both science and spirituality. For example, some interpretations of quantum mechanics suggest that consciousness plays a role in collapsing the wave function, essentially influencing the outcome of events at a fundamental level. If this is true, it could mean that our minds are more than just the sum of our brain's activity. They might be tapping into something far greater, something that exists beyond the 3 dimensions we're familiar with. The implications are staggering. If consciousness interacts with hidden dimensions, it could explain phenomena like intuition, déjà vu, or even mystical experiences. It also raises profound questions about the nature of reality itself. Are we shaping it, or is it shaping us? While this theory remains controversial and largely untested, it invites us to consider the possibility that our inner world is just as vast and mysterious as the outer cosmos. Could consciousness be the missing link in our understanding of the universe's hidden dimensions? As we ponder this question, we're reminded once again that reality is not just something we observe, it's something we actively participate in. Stepping into the realm of quantum mechanics, let's uncover a fascinating connection between quantum entanglement and hidden dimensions. Quantum entanglement, often described as spooky action at a distance, is the phenomenon where particles become linked and the state of one instantly influences the state of another, no matter how far apart they are. This defies our classical understanding of space and time, leaving scientists puzzled for decades. But what if hidden dimensions hold the key to this mystery? Some theories suggest that entangled particles might not be communicating through the three dimensions we see, but instead through higher dimensions that lie beyond our perception. In this view, the seemingly instantaneous connection between particles could be a result of shortcuts or interactions in these hidden layers of reality. For example, imagine 2 points on a piece of paper. If you fold the paper so the points touch, they become connected without traveling the length of the paper. Similarly, hidden dimensions could provide a direct pathway for entangled particles to interact, bypassing the limitations of our visible universe. This idea not only offers a potential explanation for the strange behavior of entangled particles, but also hints at how deeply intertwined our reality might be with dimensions we can't yet detect. While this remains speculative, it opens up exciting possibilities for understanding the fabric of the cosmos. As we continue to explore the quantum world, we may find that the answers to its greatest mysteries lie in the shadows of dimensions we've yet to fully comprehend. Shifting our focus to a principle that underpins much of modern physics, let's explore how symmetry might point us toward the existence of hidden dimensions. Symmetry, in the context of physics, refers to the idea that certain properties of the universe remain unchanged even when we apply transformations like rotations or reflections. It's a powerful concept that has guided scientists in understanding everything from the behavior of particles to the structure of spacetime. One of the most intriguing developments in this field is supersymmetry, a theory that proposes a deep connection between two fundamental classes of particles, fermions, which make up matter, and bosons, which carry forces. Supersymmetry suggests that for every known particle, there exists a corresponding superpartner with different properties, creating a balanced, symmetrical universe. But here's where hidden dimensions come into play. Some physicists believe that supersymmetry could only hold true if additional dimensions exist. These extra dimensions might provide the necessary framework for supersymmetric particles to interact and maintain this perfect balance. In other words, the symmetry we observe in our three-dimensional world could be just a shadow of a more complex, higher-dimensional reality. While supersymmetry remains unproven experimentally, it offers a compelling way to think about how hidden dimensions might shape the fundamental laws of the universe. As we continue to search for evidence of supersymmetry, we may find that the answers lie not just in the particles we can detect, but in the dimensions we can't yet see. This interplay between symmetry and hidden dimensions reminds us that the universe's secrets are often hidden in plain sight, waiting to be uncovered through the lens of deeper understanding. As we venture into the next layer of possibilities, let's consider a theory that stretches our imagination even further: the extra-dimensional life hypothesis. What if life isn't confined to the three-dimensional space we're familiar with? What if beings exist in higher dimensions completely beyond our perception? This idea isn't just science fiction, it's a serious scientific hypothesis that challenges our understanding of biology and physics. In our three-dimensional world, life as we know it is bound by the laws of chemistry and biology. But in higher dimensions, the rules could be entirely different. Imagine life forms that interact with more spatial dimensions than we can perceive. Their biology might involve structures and processes that are impossible in our limited framework. For instance, in 4 or more dimensions, organisms could have more complex circulatory systems, nervous systems, or even forms of communication that are unimaginable to us. These beings might navigate their environment in ways that would seem like magic or advanced technology to us, but here's where it gets even more fascinating. If life exists in higher dimensions, it could explain some of the mysteries we've yet to solve. Phenomena like dark matter or dark energy, which seem to influence our universe but remain invisible, might be the work of extra-dimensional life forms interacting with our reality. Additionally, this hypothesis could reshape our search for extraterrestrial life. Instead of looking for planets similar to Earth, we might need to consider the possibility of life in dimensions we can't yet access or detect. While this idea remains speculative, it opens up a thrilling frontier for exploration, blending physics, biology, and philosophy. The extra-dimensional life hypothesis forces us to ask, are we alone in the universe, or are we simply unable to perceive the life that's already around us? As we continue to probe the mysteries of the cosmos, this theory reminds us that reality might be far stranger and more diverse than we've ever imagined. Moving from the intriguing possibilities of extra-dimensional life, let's now step into a theory that suggests the universe itself might be a fractal, a pattern that repeats infinitely at every scale. The fractal universe theory proposes that the cosmos is structured in a way where the same geometric shapes and patterns appear no matter how big or small you zoom in. Think of it like a cosmic kaleidoscope where the design you see in a galaxy might also appear in the tiniest particles. This idea isn't just about aesthetics, it hints at a deeper order in the universe, one that could involve hidden dimensions. Fractals are shapes that repeat themselves across different scales, and if the universe follows this principle, it could mean that dimensions themselves are nested within each other. For example, the way galaxies spiral might mirror the way atoms are arranged, suggesting that the same rules apply at vastly different levels of existence. This theory could also explain why certain physical laws seem to hold true across the cosmos because they're part of a repeating fractal pattern. Some scientists even suggest that if the universe is fractal, it might not have a true beginning or end, but instead, it's an endless cycle of patterns unfolding in higher dimensions. This would challenge our linear understanding of time and space, proposing instead a universe that's endlessly interconnected. While the fractal universe theory is still largely theoretical, it offers a fascinating way to think about the hidden dimensions of reality, suggesting that the cosmos might be far more intricate and interconnected than we've ever imagined. As we peel back the layers of this idea, one thing becomes clear. The universe might not just be expanding, it might be unfolding, repeating, and echoing itself in ways we're only beginning to understand. Shifting our focus from the cosmic patterns of the fractal universe theory, let's explore how mathematics might hold the key to unraveling the mysteries of hidden dimensions. Mathematics has long been the language of the universe, and advanced theories like Calabi-Yau manifolds could be the blueprint for understanding the shape and structure of these unseen dimensions. Calabi-Yau manifolds are complex geometric shapes that arise in string theory, and they're believed to describe the compacted dimensions we can't observe directly. Imagine these manifolds as intricate, multi-dimensional knots, each twist and turn representing a possible pathway through hidden realms. These shapes aren't just abstract concepts, they're essential for explaining how particles and forces interact across different dimensions. For instance, the way a particle moves through space might depend on the specific geometry of these manifolds, influencing everything from gravity to quantum mechanics. The beauty of Calabi-Yau manifolds lies in their ability to provide a mathematical framework that ties together seemingly unrelated phenomena, offering a glimpse into the hidden architecture of reality. While these ideas might sound abstract, they're grounded in rigorous mathematical principles, suggesting that the cosmos might be far more structured than we perceive. As we delve deeper into the role of mathematics, one thing becomes clear. The universe might not just be governed by laws, it might be shaped by them, with hidden dimensions encoded in the very fabric of mathematical theory. This brings us to the edge of understanding, where numbers and equations might reveal the secrets of dimensions we've yet to see. Building on the mathematical elegance of Calabi-Yau manifolds, let's venture into a theory that stretches the boundaries of our imagination, the parallel universes theory. Picture our universe as just one page in an infinite book, each page representing a separate reality, coexisting alongside ours but hidden in dimensions we can't perceive. These parallel universes, or multiverses, aren't merely science fiction, they're grounded in serious scientific thought. The idea suggests that every possible outcome of every event actually happens, but in a different universe. For instance, in one universe, you might have made a different choice this morning, leading to an entirely different day. In another, the laws of physics might be so alien that life as we know it couldn't exist. Hidden dimensions play a crucial role in this theory, acting as the unseen barriers that keep these universes separate. Some physicists propose that these dimensions could be folded or twisted, much like the Calabi-Yau shapes we just explored, creating pathways or brains that could theoretically connect these realities. While we can't yet observe these parallel universes directly, their existence could explain strange phenomena like the mysterious behavior of quantum particles or the perplexing fine-tuning of our universe. The parallel universes theory doesn't just expand our understanding of reality, it challenges us to rethink our place in the cosmos. Are we alone, or is every possible version of us living out alternate lives in unseen dimensions? As we ponder this, we're reminded that the universe, and perhaps the multiverse, is stranger and more wondrous than we ever imagined. Shifting our focus to a fundamental force that shapes our reality, let's delve into the intriguing relationship between light, electromagnetism, and the hidden dimensions of the universe. Light, as we know it, is the cornerstone of how we perceive the world around us. But what if its behavior holds clues to dimensions beyond our grasp? Some theories suggest that hidden dimensions could subtly alter the way light travels, potentially bending its path or changing its properties in ways we can't yet fully understand. For example, light waves might leak into these extra dimensions, creating anomalies in how we observe it. Electromagnetism, one of the four fundamental forces, could also be influenced by these unseen dimensions. Scientists speculate that the strength and behavior of electromagnetic fields might be shaped by interactions with higher dimensional space, offering a possible explanation for why this force behaves the way it does. Experiments in particle physics, particularly those studying the behavior of photons and other electromagnetic phenomena, could one day uncover evidence of these hidden dimensions. Imagine a scenario where light doesn't just travel in straight lines but interacts with unseen folds of space, revealing a richer, more complex universe than we've ever imagined. This theory not only challenges our understanding of light and electromagnetism, but also opens up new possibilities for detecting the hidden dimensions that might shape the very fabric of reality. As we continue to explore the mysteries of light, we're reminded that even the most familiar aspects of our universe may hold secrets waiting to be uncovered. Now, as we approach the culmination of our journey through the hidden dimensions of reality, we arrive at the ultimate quest, the search for a unified theory of everything. This theory aims to explain all the forces, dimensions, and fundamental aspects of the universe in one cohesive framework. It's the holy grail of physics, a dream that has eluded scientists for decades but continues to drive groundbreaking research and discovery. Currently, our understanding of the universe is divided into two major frameworks: general relativity, which describes the force of gravity and the large-scale structure of spacetime, and quantum mechanics, which governs the behavior of particles at the smallest scales. These two theories, while incredibly successful in their own domains, are fundamentally incompatible. A unified theory would bridge this gap, offering a single explanation that works across all scales and dimensions. String theory and M-theory are among the leading candidates, suggesting that the universe's fundamental building blocks are tiny vibrating strings or membranes existing in higher dimensional space. Similarly, theories like loop quantum gravity and the holographic principle offer alternative approaches to unifying gravity and quantum mechanics. What makes this quest so compelling is its potential to answer some of the most profound questions about our existence. Why are there four fundamental forces? How do hidden dimensions shape the fabric of reality? What is the true nature of space-time? While we haven't yet found the ultimate theory, each step forward brings us closer to understanding the universe's deepest secrets. Experiments in particle accelerators, observations of the cosmos, and advancements in theoretical physics continue to provide tantalizing clues. The journey toward the theory of everything is not just a scientific endeavor, but a testament to humanity's unrelenting curiosity and desire to uncover the truth. As we conclude our exploration of these 30 theories, we're reminded that the universe is far more complex and mysterious than we ever imagined, and that the quest to understand it is far from over. And now, as we bring this journey to a close, let's take a moment to reflect on the incredible theories we've explored. From the intricate vibrations of string theory to the mind-bending possibilities of the multiverse, each of these 30 ideas offers a unique lens through which to view the hidden dimensions of reality. They challenge our assumptions, push the boundaries of science, and invite us to imagine a universe far more complex and wondrous than we've ever known. Whether it's the holographic principle suggesting our reality is a projection or the idea that black holes could be gateways to other dimensions, these theories remind us that the universe is full of mysteries waiting to be unraveled. They don't just deepen our understanding, they open up new questions, new possibilities, and new avenues for exploration. So, which of these theories captured your imagination? Was it the thought of parallel universes or the idea that time itself might be a hidden dimension? Share your thoughts in the comments below. We'd love to hear which one intrigues you most. And if you've enjoyed this deep dive into the hidden dimensions of reality, don't forget to hit that subscribe button and ring the notification bell. There's so much more to explore, from the mysteries of the cosmos to the cutting-edge science shaping our understanding of the universe. Thanks for joining us on this journey. Stay curious, keep questioning, and we'll see you in the next video.